Hello everyone, welcome back to my board. So today we're tackling number bases. At the end we'll learn how to solve this question. So let's start from the beginning. What is a number base?
Welcome to Don to Mon, where we learn, think, and grow. Let's explore together.
Bases are always greater than the digits. So you might not understand what this means. So let's say, for example, base 2 consists of the digits 0 and 1. Base 3 consists of the digits 0, 1 and 2. Base 4 consists of the digits 0, 1, 2, 3. You can see all of them are lesser than the base. That is what base is. So let's tackle a question like this. Convert 1010 base 2 to base 10. So I follow the same pattern that we use here. Base 2 is only consisting of 0 and 1. So let's convert it to base 10. So what do we do here? First of all, we bring the 1010 base 2 out. And then after that, we count the numbers backwards. 0, 1, 2, 3. Great. Then after that, we open up a bracket. Then we start from this one. We start from one individual number. So 1 times the base 2. And what's on top of 1? 3. And that 3 will be our raised to the power plus, open another bracket, for 0 times 2. This base raised to the power of 2, what's on top of 0, plus 1. We're going to do it for 1. So 1 times 2, base 2. What's on top of 1? 1. Plus, we're going to do it for this 0 times the base 2. And what's on top of 0? 0. Close the bracket. So 1 times 2 raised to the power of 3. Keep in mind, 2 raised to the power of 3, it's not 2 times 3. It's not 2 plus 3. But it's 2 in 3 places. What do I mean? It's 2 times 2 times 2. If it's 2 raised to the power of 4, it's 2 times 2 times 2 times 2. So 2 times 2, 4. 4 times 2, 8. So we bring it down. 1 times 2 raised to the power of 3, 8, plus 0. We bring it down. 0 times 2 raised to the power of 2. 2 in 2 places. 2 times 2, and that's 4. So we bring the 4 down here, plus 1 times 2 in 1 places is just the same thing as 2. So you bring it down here, 1 times 2, plus, when you have something like this, it's the same thing as 2 in 0 places. But we don't say 0. We don't say 2. We say 1. Any number that has a raised to the power of 0 is 1. Infinity raised to the power of 0 is 1. We're going to bring this 0 down, times 2 raised to the power of 0, 1, close bracket. 1 times 8 is 8, plus 0 times 4, 0, plus 1 times 2, 2, plus 0 times 1, 0. So 8 plus 0, 8. 8 plus 2, 10. 10 plus 0, 10. So the answer is 10 base 10. So this is the method to convert any base, not only base 2, to base 10. When you want to transform base 10 back to any other base, you can use the tabular method. You might recognize it in LCM and HCF. So let's make a table consisting of 3 columns. Then this 10, we put it here. This base 2, since we're converting it back to base 2, we're going to put a 2 right here. And after that, we're going to put a remainder. We put a remainder here because sometimes 2 can divide a number and give an exact result without giving any decimals. So that is why we put our remainder, and it is also the most important part. So 10 divided by 2, 5. 2 times 5, 10. 10 minus 10, 0. That is because it has no remainder. So 5 divided by 2, 2. 2 times 2, 4. 5 minus 4, 1, because it has a remainder. 2. So 1. 2 divided by 2 is 1. Remainder 0, because 2 times 1 is 2. So when we had this, 1 can't divide 2 because 2 is greater than 1. So we put a 0, and since the 1 remained untouched, we're going to put back our 1. So the answer is 0, 1, 0, 1. Wrong. So when we want to turn it to base 2, we're going to count from the bottom up. So instead of starting from 0, we start from 1. 1, then 0, then 1, then 0. Base 2. So didn't we get the same answer? 1, 0, 1, 0, base 2. Now let's see if we can do this in every single base. So let's try something harder. So as you can see right here, base 8, you can see that the base is greater than 2 of these numbers. As you know, 8 is greater than 7, and it's of course greater than 2. What we do to get base 10? We do the same thing. We bring the 72 base 8 over here, then 0 and 1. So we now start from this 7. 7 times, what's our base? Our base is 8. 7 times 8, what's on top of 7? 1, close bracket, plus 2 times 8, what's on top of 2? 0, and that's what will be our raised to the power. So 7 times 8 raised to the power of 1, That is the same thing as 8, as I've already said, plus 2 times, as I told you before, infinity raised to the power of 0 is 1. Any number raised to the power of 0 is 1. So 7 times 8, 56, plus 2 times 1, 2. 56 plus 2 is 58 base 10. That is how to turn any other base to base 10. Remember, this number is always the base. Now, let's try to turn it back to base 8. So, 58, 10, 2, base 8. So we draw a table. 58. What are we changing it back to? 8. And the remainder. 58 divided by 8, that's 7. 8 times 7 is 56. 58 minus 56 is 2. So, when we see this, I've already told you 7 can divide 8 since 8 is greater. So, we write 0, and since nothing affected the 7, we write it here. So, we count it up like we did the last time, and it's 72 base 8. Didn't we not get the same answer that we did before? So this is how to convert any base to base 8 or any other base. This is how to convert base 10 to any other base. So let's try something a little bit more tricky. Okay, so we're changing from a base to any other base without base 10 being involved. So now let's look at this question. We don't divide it. We don't use the tabular method, but we turn this 72 base 8 to base 10 because the tabular method only works when converting base 10 to base 2. So, as we already discovered, 72 base 8 is equal to 58 base 10. So, since we already know, we don't have to go through all that problem. So, we can just draw the table. 58 remainder, and what are we changing it to? 2. So the 8 divided by 2 is 29. Remainder 0, because 2 times 29 is 58. Okay, so 2 in 29 is 14. 2 times 14 is 28. 29 minus 28 is and 2. So 14 divided by 2, that is 7. Remainder 0. So 2 and 7 is 3. Remainder 1. So 2, 3 divided by 2 is 1. Remainder 1. So, as you know, 1 can divide 2 because 2 is greater than 1. So we put 0, and since nothing affected the 1, we put the 1. We counted from the bottom up, and instead of starting from this 0, we start from 1. 1, 1, 1, 0, 1, 0. So that is how I converted 72 base 8 to base 2 by first changing the base 8 to base 10 so that I can be eligible to use the tabular method. So let's get into something bigger. Okay, so now let's get back to the board. Now, when you don't want to say base 2, base 8, or base 10, they have specific names that you can give them. Base 2 is called binary. Base 8 is called octal. Base 10 is called decimal or dinary. So when you see convert 1011 base 2 to decimal, you won't be scratching your head. So let's go beyond decimal and let's see if we know what hexadecimal is. As you know, hexa means 6 and decimal, as I told you before, is referred to as 10. So that means it's base 16. So when we want to count base 16 here, when we want to write the digits for base 16 are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We can't write 10 because 10 is a combination of 0 and 1. We can't write 11 either because of the combination of 2 1s. So what do we write? We count from uppercase A, then uppercase B, then uppercase C, then uppercase D, then uppercase E, then uppercase F. And as we know, A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So it's very important that we have to count from uppercase. So when we are greeted with a question like this, when we're tackled with a question like this, we're going to solve it like this. So we bring the 4 down, the B down, the D down base 16. And as you know, you write 0, 1, and 2. So we open bracket 4 times, what's the base? The base is 16. What's on top of 4? 2. Close bracket plus B times the base 16. What's on top of B? 1. Plus D times 16. What's on top of D? 0. And now 16 in 2 places is 16 times 16, 256. So we have already found out that 4 times 256. So it's the same thing as 16. What is B? B, from what we know here, is 11. So we write 11 times 16 in one place is 16. Plus D. D is 13. So 13 times 16 raised to the power of 0 is the same thing as 1. So we write it down. 4 times 256. So 4 times 256 is 1024. Plus 11 times 16 is 176. So plus 13 times 1 is 13. So we plus all of this. 1024 plus 176 plus 13. Drop your answer in the comment section below. And I'm Timon and I'm signing out.